Okay, so hello and welcome to this new lecture in the ongoing series of lectures on digital prepress. Now, in this lecture, we are going to study about a very important concept which we are going to be using a lot, I think, during image correction. That concept stems from the fact that how differently a camera sensor perceives light and how a human eye perceives light. So from that point of view, we will be beginning our study. So this is basically, you can call this to be the tone compression, or what we refer to as gamma. So initially I am not going to talk all about the formula and all. Let us start right from the very basic idea. Okay, take a look at the first picture over here, this one, right? Let me just mark it out. Yeah, take a look at the first picture here, picture 1 and picture 2. Now don't get afraid because of all these curves and all. I'll explain what all this means. See, normally what do you expect from any sensor, any light sensor? What I mean to say is that suppose your eyes are receiving certain quantity of light, actual light, and with respect to that, how much of it are you perceiving? Perceiving means how much of it you are really seeing. Let us say are your eyes are receiving 50% light, 50 units of light, let us say. Okay, so normally you will perceive, it is expected that you will perceive this 50 units of light as 50 units of light. Are you getting what I am saying? I am saying that if 50 units of light reaches your eyes, it is expected, normally it is expected that we will perceive that to be 50 units of light. Is it not? It's a quite feasible and it's a quite logical expectation, right? Now, the problem is that doesn't happen. If you remember, I don't know whether I told this or not. If you remember, when I was teaching you that characteristic curve in prepress repro, there we spent a lot of time on this characteristic curve and the various nature of the plots and all this and that. So what do we call characteristic curve? Another name for characteristic curve was d log e, density versus log of exposure. Uh, I think I told you, or even if I didn't, did you ask that why we're using this logarithmic scale in the x-axis? Density is okay, fine. Density you are using absolute scale, I mean linear scale. But in case of exposure, you are using a logarithmic scale. Why? Why are you using this? It comes from this fact, what I'm going to tell you now. Our eyes' behavior is non-linear. What does it mean? Take the first example that I told you. When our eyes are receiving 50 units of light, you are thinking, okay, 50 units is light, is 50 units. We are perceiving that. But I don't know what 50 units of light is. I mean, my eyes is not a calculator. My eyes will not say that, okay, this is 50 units of light. I will not understand. Let us understand it in a little bit deeper way. Let us assume that there are two light sources. One is 50 units and the other is 100 units. Okay. Now, it is expected under normal circumstances that the we will perceive, we means our eyes will perceive that the 100 units of light will be twice as bright as the 50 units of light. Is it not? Is it a fair assumption? Is it a logical assumption to assume? It's quite fair. It is what I can expect. But this does not happen. Our eyes does not perceive that 100 units of light to be as twice as bright than the 50 units. This is the nature of our eyes, or the behavior. There is a very nice reason for this to happen. Ultimately, what happens, our eyes are more susceptible towards the darker tones than towards the lighter tones or light areas. That means any small uh, difference in some darker tones our eyes can perceive, but the same difference, even if it happens in the lighter tones, that difference our eyes cannot perceive that very well. Now, can you tell me why this happens? Why our eyes, why nature has, you know, what should I say, designed our eyes in such a way? Can you tell me? Think about it for a minute. There's a very logical explanation behind it. You don't need to know any, science or this biology or maths to unravel the mystery here. It's a very logical thing that nature, Mother Nature, has given in us while developing our eyes. Just pause the video here for a minute. You think about the answer. I'll tell you the answer right now only. See, uh, now you are sitting in a room, let us say, inside of your room in your house, and it's daytime, it's midday or late in the afternoon, and you suddenly go out, walk out of your room outside. Tremendous sun. When I'm recording this video, it's extremely sunny and it's extremely hot. Now, right now, if anyone, you just go out of our room outside, what will we do? We'll first put our hands in front of our eyes just to block some of the light. So much amount of light will come over, and we will be overwhelmed. Our iris will start first to, it will contract to reduce the amount of light that enters into our eyes, so that we get used to it. But in darker areas, I mean, imagine the opposite thing. You know, it's very sunny outside, and you came into your room. It's not that well lit. Light is not switched on, and the windows are also closed, and the curtains are also closed. So, what will happen if you do not switch on the light immediately? You will try to widen your eyes to find out, so that you are allowing larger amount of light to enter. Ultimately, what you will see, that the reason why this happens is that why we are not able to detect small changes in luminance values when it is brightly lit is because when it is brightly lit outside or in any environment, our eyes are overwhelmed with so much amount of light. We are not able to understand. But when it is darker, that time our eyes are more susceptible to those small changes of light. That is why this happens. Okay, so ultimately this is uh, you know a design. By design, our eyes have been made non-linear in its response, and it is precisely because of this reason, for any uh, you know uh, exposure related calculations and plotting, we use a logarithmic scale of exposure, which correlates with the response of our eyes. Logarithmic scale correlates with the response of our eyes. Now, coming back to so this is the background. Okay. Now let us take a look at what is happening in terms of this, when we how we correlate this concept towards this curve. Okay. Now let us see. As I already told you that this is 25% incoming, 25 units incoming light. Okay. Our eyes are perceiving 25% light as how much? Around 50, maybe 55 or 52 something. Okay. And so naturally, when we would receive 50 units of light, first of all, it was expected of us that our eyes would perceive 25 units of light as 25 units. That did not happen. Our eyes perceives 25 units of light as much more than 25 units, almost more than the double value. This is the first thing to notice. The second thing to notice is that for double the quantity of light, let us consider 50 units of light. If we expect that for 25 units of light, our eyes are perceiving 25 as 55 units. Fine. We can expect that for double that value, that means for 50 units of light, our eyes will perceive that light as 100 or 110, something like that, double, proportionately double, right? But does that happen? Let us see. No, that is not happening. Our eyes are perceiving 50 units of light as 75 units of light only. So here also there is a problem. So ultimately, when you take a look at this curve, this is that blue colored curve. If you take a look at this, what will you notice? The rate of increase of perception towards luminance by our eyes is very high in the darker to mid-tone areas, but it is that rate reduces when the luminance is increased. That means the slope of this curve at this area, I'm sorry, the slope of this curve at this particular area is quite high, but this is the shadow area, this is the darker area, but at this region, that same the slope of the same curve becomes lower. That means in light, well lit areas, our eyes are not able to perceive that much amount of difference in light. That is why for 20, we expected for 25, we know that for 25 units of light we are expecting 55 units, but we expected that for 50 units it should have been 110 units, but that did not happen because our eyes at 50 does not perceive that to be 50. It perceives it to be lower than 110. Okay, this non-linearity in the response of our eyes makes it challenging to uh, visualize and store digital images which we take with the help of a camera. Why does it happen? You see, this is another part of the picture now becomes clear. Come to the second thing, this second curve. This blue colored curve is clear to you. Now come to this violet colored curve. Huh? This is a straight line. This line is the transfer function for a optical sensor of a camera. This is linear in nature. That means what? A camera sensor will perceive 25 units of light as 25. How? See here, 25 units of light is perceived as 25. So, for as our expectation was initially, or as our assumption was initially, that double the light value we will perceive double light, but that did not turn out to be true for our eyes. But for the camera sensor, that is true. Why? For double the value, 50, when the 50 units of light is reaching the camera, then that will be recorded, or that will be perceived by the camera sensor as 50%. So camera sensors are linear in their response. Our eyes are non-linear in their response. Now you will say, why all these things you are teaching? Yes. Now let us come to the main part. Because we have now known what bit depth is, there is a correlation between bit depth, gamma, images and image correction. Okay, let us take a look. See, this one is the original image. This is a scene, suppose. Okay, this is the original. This is a grayscale, continuous tone grayscale, or you are capturing a image with the help of a camera. Okay, you need to, for saving it, for digitizing it, you need to discretize the levels. You need to break down the levels into few intervals. Maybe you require 8 bits, maybe you require 16 bits, no matter how many bits, but you need a few bits to discretize the tonal values, to save them in certain discrete packets, which we learnt as the pixel intensity values, what Photoshop calls as levels. We need to break down this entire grayscale into those few levels. If you are using an 8-bit system, then 256 levels, 16-bit system, then 65,536 levels, etc. Is it not? Now see what happens if we encode this using 5-bit system and encode how? Encode linearly. Here you see one interesting thing is happening. Because of the nature of the camera sensor, which is working linearly, what happens? It becomes more susceptible towards the lighter tones. That means camera sensors will pick up more information in the highlight area or in the lighter tones than in the shadow tones. That is why when you are encoding this information, where you are encoding or discretizing this, the camera sensor or the camera assembly will allocate more bits for the highlight area than the shadow areas. More bits will be assigned for the highlight area than in the shadow area. As a result of this, what will happen? The entire image will become very much, lightened up, or the highlight area will become dominant in that area, and the shadow areas will lose almost all the information because there are not enough number of tones available in the shadow area to represent them. Who will represent? These levels in the shadow areas will reduce because your camera sensors are more susceptible to the lighter tones. More bits will be allocated to the lighter tones. More levels will be assigned in the lighter tones in the highlight area than in the shadow area. Is it not? But this is a very inefficient method of storing images. Okay. Now you see this. Now the concept of gamma comes. Why gamma encoding is to be done? This gamma encoding redistributes the tonal levels, that is much more at tandem or much more closer to our eyes response towards light, and therefore the fewer bits are needed to represent this tonal range. Otherwise, what happens, as you can see in front of your screen, the second image, that greater number of bits will be required to describe the lighter tones, where the camera sensor is more, susceptible, and there will be not enough number of tones in the shadow areas. Now, for this, because this linear encoding has limited number of tones in the darker areas, this automatically entails what? That there is an excess in the excess of highlight area, or the dominance of highlight area in any of the all the images that is linearly encoded. But for the gamma encoded, the entire grayscale that is redistributed in such a way which represents more closely with our human perception. That means here you will see that greater number of tones have been allocated in the darker tones than in your lighter tones. That means what? When you gamma encode a particular image while storing the image, digital image, then you are making that more perceptually, that is your image that is stored will become more perceptually uniform. What do you mean by perceptually uniform? That means amount of information that you get in the shadow areas will be higher in comparison to a linear encoded data. This is your linear encoded data. This is your gamma encoded data. I will show you how gamma encoding is done, but hopefully this much amount of information is clear to you. Why we do gamma encoding in the first place? Why go for this? Okay. Now let us see what this gamma encoding is done, or how this gamma encoding is done. See, when you are clicking an image with your digital camera, the first step that takes place is while saving the image, automatically some gamma is applied to the image. Okay. Now here you can see what is the purpose. The purpose here is for recording the image. Why it is important? Because that will ensure that the total number of bits that is required to save the image is not high. Why am I saying is not high? Why it will become high? Because if you see here, you have you are using a 5-bit system in this particular picture. You are using a 5-bit system. So how many levels? 32 system. 32 levels. Now, if you are linearly encoding the image, if you are not, applying gamma to your image, then what is going to happen? Most of the tonal levels or most of your levels will be applied along the highlight areas, and not these areas will be left out. But when you gamma encode it, see, all the levels are such uniformly distributed so that enough amount of or enough number of levels are there in the shadow area also to record that information, such that the image that you see will become more perceptually uniform. Otherwise, what is happening? Let me show you. This is linearly encoded data. See, oh, acha, another thing that I forgot to tell, why that I was saying that why greater number of this thing is required, bits are required. Now, see, if you are, bent on saying that, okay, no, sir, I will not use gamma, but I want a very good output. Okay, then what is your option? In that situation, you need to increase your byte size. You need to increase your bit size or bit depth. Why? Because you need to ensure there are larger number of tones available in the shadow areas as well. How to ensure that? You need to increase the number of bit depth. So instead of 5 bit, you may go up to 10 bit, 11 bit, 12 bit, etc. Just to ensure that the number of bits available, or sorry, number of levels or tones available in the darker areas, in the shadow areas, are also sufficiently enough to record and capture the shadow details while you are capturing the image with your camera, right? But that is one possibility, increase the bit depth of the image. So increasing the bit depth will ensure what? It will increase the file size also. But I am saying to you that you do not need to do that. You have a much more efficient method of storing your image with less number of less amount of memory requirement. You can use a 5-bit image, you can use a 5-bit depth storage value, but only you need to do what? You need to encode your image with a suitable gamma such that the tone values are redistributed in such a way that you have sufficiently enough number of tones or levels in the shadow areas as well in comparison to your highlight area. Okay, now let us see what is I will come back to this with this curve later, but before that I want to talk about this. See, what is going to happen if you are not rendering your image or not storing your image with any gamma encoding. You are simply linearly encoding your data, your image. What is going to happen? Your image will appear like this. I don't know if you have seen it or not. Certain cameras which your professional grade camera, when you take the image in a raw format and you import it in Lightroom or Photoshop or whatever editing software you're using, appearance is very dark. I don't know if you have seen this. When the appearance is dark, that means no gamma encoding has been done by your camera. It is raw. That means unprocessed basically. Raw means unprocessed. Digital negative, what Adobe calls. So why is it dark? Now the question is, why is it dark? If your image has been linearly encoded, why is it dark? Because there are not simply enough number of tones available in the darker areas, in the shadow areas, to store that data. So all these areas which are shadow areas, all these areas, the information has been lost. Your camera was not able to record or save this data because it was not gamma encoded, or at least you are not able to. Even if your camera recorded it, you are not able to see it on the screen. So that is why you need to encode all these cameras and all this software automatically encodes your data or image with a certain gamma. Normally it's 2.2. Nowadays standard is I think 2.2 only. Earlier Max and all, I think it was 1.8 or something. And in CRTs it used to be higher than this, 2.5 or something like that. Okay, but normally it's 2.2. So this is your input, what we call is the image gamma. That is what your camera assembly is adding or encoding your image with. There must be option if you want to remove the gamma correction or gamma encoding option, you can do that also. But by default in many cameras you will find out that there is gamma encoding available. Whenever you are saving that image as a JPEG, then it will be saved with a gamma encoding. Okay, normally RAWs do not, the purpose of RAW is to ensure that your photographer gets a lot of leeway to work on that or edit that image. So in RAWs you might not be having your gamma encoding, but for JPEGs, when you are saving those RAW into your JPEGs, then automatically your camera or your software, whatever it is, they will add on top of that, they will encode, they will gamma encode your image with certain value. Okay, now the question is, this is fine, this is okay. Now gamma has been encoded, right? What does it do? It kind of redistributes your entire tonal values or number of tones in such a way that the image becomes more perceptually uniform, and if very that ensures what, a very efficient use of the bit depth. So you do not, as I told you earlier also, that you do not, sorry, need additional number of bits to, you know, cater for the loss of the number of tones in the shadow areas or loss of the shadow details. Okay, now next in the middle that you can see, number 2 is the display gamma. This display gamma, whenever, first step is what, gamma has been, your image has been gamma encoded and saved in your camera or saved in your software. Okay, while visualizing this, while you are just double clicking and opening it with your on your computer or on your whatever it is, your computer has got a video card, right, a graphics card. It may be yeah, which is a graphics card is something which is driving your display, right? Now the main purpose of this display gamma is to compensate for this image gamma that has been used to encode the file with. And ultimately the purpose is what, this ensures that the overall image has not been unnecessarily brightened. Now see, what is going to happen if you are encoding your image with a gamma like this? What is going to happen? Your image will become brightened. Why brightened? Because you see, there will be larger number of tones in the shadow areas. That means overall there will be increase in the brightness of the image, right? So in order to ensure that you get the accurate representation of the image or the accurate nature of the image that was captured is visible to you on your display, the before viewing this JPEG, your computer's video or your display's video card decodes the image with the reverse of that gamma. So if your original gamma was 2.2 or whatever it is, so then it is decoded with 1 by 2.2 reciprocal of that. That looks like something like this. So the ultimate effect of the image is a linear image which is perceptually uniform. That means that the tones are equally redistributed throughout the image. Okay, hopefully this much is clear. This I have already sorry, uh, this one I have already told you. Yeah. Okay, so yes, now let us take a look at what is the effect of changing display gamma. Changing display gamma means this value. When we are changing, so this is let us say this is let us assume, as I told you, that this is actually display gamma is 2.2. Normally for displays it is 2.2. Okay, so image gamma will become the reciprocal of that, that is 1.1 by 2.2, or for CRTs it used to be, I think, 2, as I told, 2.5, and earlier max or old model of max used to be 1.8. The display gammas used to be 1.8. So for display we'll also be talking about how this is actually done in the entire process, but not at this class, because this is a subject that we need to address in our elective class when we are talking about display calibration or display characterization. There we will be talking about how video cards are used for rendering or color correcting your display. Color temperatures are adjusted, and there are certain inbuilt loops or lookup tables. So those are the subject of the elective class, but right now we know that display gamma is normally 2.2. Also, before moving ahead, I just want to go back and show you that relationship that I. So mathematical, now you have got a fair bit of idea about what gamma is. This is what I told you, that there are normally for your what should I say, a linearly spread out uh, image or linearly encoded image, there are not enough number of tones that are available everywhere. These tones are not equally distributed throughout the entire tonal range. This is why gamma is required. So that with the same number of bits, that is with the same amount of memory, you can redistribute your tones in such a way which is perceptually uniform. That means which corresponds with the perception of lightness of our eyes. What you are seeing on the screen, what you are visualizing, that matches with each other. That is why gamma is required. So mathematically, gamma can be described as B is equal to D to the power gamma. B here is a brightness value and D is the digital value. Digital value means pixel intensity, and brightness is what brightness of light or the luminance that is coming to our eyes. So this exponential equation is where we get gamma from. Okay. Now let us talk a little bit about the impact of gamma on the various images. So one thing is clear, more linear the images. So let us say gamma is 1, that means it's a linear scale, right? If your gamma is 1, that means no correction has been done, then the overall nature of the image, without any gamma correction I mean, the overall nature of the image will become what? It will become very much dark, not enough number of uh, tones in the darker areas will be obtained. Now let us take a look at one very important concept, that as I told you, this display gamma, what should be the value? Now you may ask that why you are telling that this value, why you are so certain that this value is 2.2 and 2.5 and 1.8, all these values, where are you getting from? Is this kind of a trial and error that people normally do to find that sweet spot of what is the value of gamma for which you are getting the best possible output. Okay, so let us take how you can do it on your own also. I'll show you, maybe if I'll show you with the help of Photoshop or something. So yes, let us first understand this image very carefully. Okay, it's a very nice image, and I'll give you the link for the website from which I have referenced this. It's a very nice website. At the end of the class, I will, or in the Google Classroom platform, I'll give you the reference to this also, so that you can read on your own and you can develop that concept on your own also. Okay, now see, this is what, this is your image gamma, that is, this is your encoded gamma. Okay, now as I told you earlier that normally when saving the image is gamma encoded, such that there are enough number of tones in the shadow areas as well. That means what, there is a overall increase in the brightness of the image. Whenever you are applying gamma encoding or you are gamma encoding a particular image while saving it, while storing that image, then using a value, let us say 1 by 2.2 or something like that. Okay, then that results in an overall increase in the brightness of the image. Okay, now for correct visualization, when you are opening that, double click and opening that image on your computer screen, the video card, that's a graphics card what you call, this video card in your computer which is driving your display of the computer, that applies a opposite of that or reciprocal of that gamma. So that is known as gamma decoding. Your image is gamma decoded, so that the overall system gamma remains 1. So three things has to be very much clear with you. One is your image gamma, one is your display gamma, one is your system gamma, or okay, I'll explain it. So first let us very much carefully understand these terms. What is image gamma? Image gamma is the gamma value using which your image is encoded while saving that image in your computer or in your camera, etc. Okay, so that curve looks something like this. Why it will look, another question is why it will look something like this? Because there are larger number of darker tones than lighter tones, ensuring that the information obtained in the darker tones or the darker areas are also there, present there. Okay, so this will result in an overall increase in the brightness of the image. Next we have got the display gamma. What is display gamma? Just the reciprocal of the image gamma. Reciprocal of the image gamma means what? It ensures that while viewing that image in your computer, the graphics card or that video card decodes the image back to its original form. That means it is the reciprocal of that image. So image gamma is encoded, right, while storing the image. Display gamma is decoded, used for decoding while viewing the image. And what is system gamma? System gamma is basically nothing but one, that is linear scale. Okay, linear scale. Whenever we are visualizing an image, the net result of the encoding using image gamma and decoding using display gamma should always be 1. Okay, that is, it should be 1 means it should be linear, that is what I mean to say. Okay, now see, for this case here, the image has been encoded with a certain value, it's quite evident, but the display gamma is not proper. That means display gamma is 1. How much should have been the display gamma? If the input gamma, I mean the image gamma would have been 1 by 2.2, then the display gamma should have been 2.2, reciprocal of that, such that the resultant system gamma becomes linear, but that did not happen. Display gamma is lower. That means display gamma means gamma of the screen in which you are visualizing the image. That is 1. So that means what? That means your overall image is very much, highlight area is greater. I mean the overall image has been lightened up, has been brightened. Okay, so please don't be confused. See, I am saying here that this number of darker tones is higher. That means what? That means overall amount of light information that is available in your image is high. That is why overall brightening of the image occurs. Okay, now next, in this case the display gamma has been set to 1.8, that is increased, but still you see it is not 2.2. So resultant your system, this gamma is still not linear, it is a little bit lower than that, I mean greater than that. Okay, so overall there has been a significant drop in the brightness value of the image, but still it is not really at par with the original image that was recorded. What happens when we increase the gamma further to 2.2? Now you see the resultant gamma is, or the system gamma becomes linear. Now it is correct. This image is the correct image. Okay, and further if you go on increasing this gamma value, then this is overcompensation. Your system gamma drops further below, and this, what should I say, this basically increases the shadow area so much that the entire image is darkened. Okay, now another thing that I wanted to say is that here you see there is another important point, that if you see the grayscale over here, since as I told you, this is also very important to notice. Okay, as I told you that when your display gamma is not set properly, it is set at a lower value, then there will be an overall increase in the brightness. That means it will appear to be faded out. That means the highlight tones will increase in comparison to the darker tones, and as you go beyond, as you go on increasing the display gamma value, then there is a parity where this is giving you the correct grayscale. That means the tonal values or the tones have been redistributed in such a way that it gives you a perceptually uniform image to view. But if you go on increasing the gamma to an extent more than that, that ensures what, or that will lead to what, a darkening effect of the overall image. Okay, so this is what gamma is. Let me also show you that example, some a little bit of a demonstration in Photoshop of how this actually happens in real time. Okay, so let us take a look at, let me demonstrate of how this gamma value basically influences the nature of the, or the overall nature of the image in real time. So this is the image that I showed you earlier also. So let us go to let us go to the option that helps us change the gamma value. So go to image, then adjustments from the drop down, and finally go to exposure. Okay, so here you see I will not talk about the two factors that are present on top, but I'll only talk about the gamma correction. Okay, now here one important thing here, you see this this term gamma correction here, this refers to the image gamma. This basically refers to the image gamma. So which am I referring to? This curve, this violet colored curve. This is what I am going to change. Now you may ask that sir, why not change the display gamma? Can I change the display gamma using this Photoshop? No, I cannot. Display gamma is inherent to the video card of the computer. You need a specific tool to change. There are tools available for changing the entire display gamma, but I don't want to do that, because changing the display gamma beyond the default value might make the display look a little bit different. So I don't want to do that. I just want to give you an idea about what the changed image gamma value does to the overall image. Okay, so let us try to decipher over here. Now as I will move, this is a slider. Actually you can input the value manually also, but I will just move the slider left or right. Now as I move the slider to the left, the value will increase, the image gamma value will increase. So from 1 I can go to 2.2, and when I go to the right, the gamma will decrease. Gamma value, I mean image gamma value will decrease. Now the question is over here, which value am I referring to? This is very much important. It can become a little bit confusing at first, but not to worry, I will show you everything. But tell me, if I go on increasing this gamma value, this what is this image gamma value, what is going to happen to the nature of the image if I go on increasing this value I have showed you on the screen? What is going to happen to the image? Is it going to become more brightened, or is it going to become more darker in nature? So for that to answer, let us go back to our slide for a minute over here. See, the gamma correction tool in the Photoshop, that is which value? That is basically the image gamma. That is not really image gamma, so that is where the confusion comes from. Okay, so as I told you, for this image, let us assume that the image, this particular image, has got a gamma encoding value of 1 by 2.2. Now in Photoshop gamma correction tool, that gamma value is not this entire image gamma, this is only this value. Okay, so that means what? If I am right now, the gamma is 1, right? That means there is no gamma encoding, it is simply linear. So if I go on increasing from 1 to, if I say, let me take this value to 2.2, so what will happen? The gamma curve will become, the image will become gamma encoded, and it will become 1 by 2.2, right? So if this gamma value increases over here in Photoshop, if I from 1, if I go on, this is the value here is given as 1, if I put 2.2 here, then what will happen? The overall image, overall image will become lightened. That means it will brighten up. We are gamma encoding the image. And conversely, if I go on decreasing this gamma correction value, then it will get darker in nature. Why? Because I am using, for let us say value less than 2.2, let us say I am using 1 by 1.8 or 1.5, let us say, then instead of this curve, I will get a curve like this, somewhat like this, a curve which is having greater amount of darker tones than previously. If you compare the number of darker tones present here and in this particular picture, which is having greater number of darker tones, this one in comparison to this one, right? So with this in mind, in Photoshop, when we are doing gamma correction, if we increase the value, then overall there will be lightening. That means picture will become more brightened up. Why? The curve is increasing. If we reduce that value, then the curve is decreasing. That means shadow area. So let me just write 2.2 over here. 0.2. Oh, sorry. 2.2. See, there is an overall increase in the brightness of the image, fading out effect, right? Because the number of tones in the darker areas have also been reassigned, perceptually more uniform. And if I go on increasing this to 2.8 let us say, it becomes more you know this lighter, brightened up. Okay, now let us say I give it less than 1. Okay, that means let us say 0.5 value. Okay, this becomes darker. So is it matching with whatever I have taught you over here? You go on you go on reducing the display gamma value. That means from 2.2 to 1.5 to 1 to 0.8, you go on reducing the gamma value. What will happen? The image will become more darker in nature. Huh? And conversely, what I taught you here is that for display gamma, so hopefully this Photoshop part is clear. Hopefully this part is clear. Now again I am going to repeat this display gamma because you might feel a little bit confused here, because there in Photoshop we talked about the image gamma, but in this context we are keeping the image gamma fixed to 1 by 2.2. We are keeping that fixed, we are not changing it. But what were we changing? We are changing the display gamma, that means the gamma of the entire screen itself. That you can do, that Windows have some tools there, you can search for those tools, and there are some third-party tools also, but I do not suggest that, because you simply do not change the display gamma. That can result in some deterioration of the image quality also, computer screen, etc. So I do not recommend using those tools. That is why I showed you the live example of the image gamma, not display gamma. But in this context, whatever I told you, result is almost the same. See, the image gamma when it is low, that means the overall system gamma is not that high, right? That means what? There is an overall brightening up of the image, and as you go on increasing the system the display gamma, what is happening? The system gamma is reaching a linear state, and when the system gamma reaches the linear state, then the number of tones on either side, that is the dark side and the shadow side, shadow side and the highlight side, they become perceptually uniform, equal number of tones spread throughout at the same number of bit depth. But if you go on increasing the display gamma further, then there will be overcompensation. Then the overall image quality will, the image will become more darker image. Okay, so hopefully there was no confusion whatever I told you today. Okay, so thank you for listening in.